Right, good morning all lads. What we're going to do today is have a look at Ohm's Law basically this morning, and then this afternoon we're just going to extend the subject a little more to include what happens when cables get warm, etc. So you remember from last week we have our basic circuit, which is a supply, and we have a load here like that. Now I've left the switch out and I've left the circuit protection out just to keep it simple, and just move the camera down there so you can see that. And what we're going to try and demonstrate is this basic law, which is that the current flowing in a circuit is directly proportional to the voltage applied, and this is Ohm's law. And he was the first guy, he was a physicist who discovered this fact. It's a very important law in electrical engineering, and it's something you need to remember. Most of the calculations that you'll do in electrical engineering in the future will be based on Ohm's law theory. Fairly simple. Here we have a voltage, and we know that a current I is going to flow through there, and this load here that we have has resistance R. And what we're going to demonstrate is that if we increase this voltage, what happens to this current? So this is the pressure forcing the electrons around the circuit, and this is the current flowing through it. In order to do that though, we need 2 meters. So I'm going to break the circuit and put my ammeter in there. So I'll put it, it's A, isn't it? I'll call it A, ammeter. Do that again. And I'm going to get another voltmeter here and connect it across the supply. And there we have the 2 meters. So it's very important when you're measuring current, you break the circuit somewhere in the chain and place your ammeter, so the voltmeter is always in parallel with the supply. Here's the rig that we showed you briefly last week, and I've got these 2 meters here which are connected in that way. So this one is connected across the supply, showing the voltage, and this one is showing the current, so it's in series with the supply. And what we can see is as we increase the voltage, this voltage is going up here, the current is going up as well. Now ordinarily, if we were in the classroom, I'd get you to have a go on one of these rigs and take the readings from these meters to plot the graph. However, you're just going to have to take my word for it that as we increase the voltage, the current increases proportionally. Now in this case, I'm driving this light bulb here, and it will introduce some error because the light bulb gets warm, and as light bulbs get warm, the resistance tends to go up, and therefore the current it blocks the current a little bit, so it gives you a slightly inaccurate result. We can get a more accurate result if we use a resistor. So if I plug this into a resistor, I'll use one of these resistors down here, we should get a slightly more accurate result. So if I have a voltage of, say, if I set that to 10 volts, this is set to 10 volts, and this is showing 45.7 milliamps. And you'll remember that milliamps is a thousandth of an amp, so it's 10 to the minus 3. So this is 10 volts, and this is 45 milliamps. If I increase that to 20 volts, just about. Probably need to go to 200 volts. If I go to 20 volts there. Oh, sorry. Yeah, that's good. If I take that up to just, the meter's going off scale there, so if I just take it to 20 volts nearly, you can see here that the current has actually doubled. And basically what Ohm's law is saying is that as you increase the voltage, the current will go up in proportion. So if I double the voltage on a load, I will double the current going in there. Okay. Now we can plot a graph of that. I'm not actually going to plot it with points, but what I will do is just show you the graph. So we have voltage up this side and current down this side. Can't see that. There you go. The result will be what we call a straight line or a linear graph. And if I have 1, 2, 3, 4, 5 volts up there, 1, 2, 3, 4, 5 amps along there, what we'll find is this: if I have 1 amp here, 1 volt there, 2 amps there, 2 volts there, we can see that this is in proportion. So in order for me to calculate what the resistance is of this circuit, I can see that that is obviously 2 volts, 1.5 amps. So it's 2 volts, 1.5 amps. And we know from Ohm's law, and the triangle that we did last week, V, I and R. I'm trying to find R, so V divided by I equals R. So 2 divided by 1.5 is 1.3 ohms. So we know the value of this resistor is 1.3 ohms. Another way of doing it is to measure the gradient of the graph, and you can do that by taking one voltage away from another and one current away from another and measuring the rise over the length. However, it's far easier with these graphs just to pick a point anywhere on the graph, go along and work out V and I. And when you've got V and I off the graph, you can then work out the resistance. Let's try another one. Well, I've still got a minute left on the video. There's a quick one there. There's the line. That could be 2 volts, 4 volts, 6 volts, 8 volts. That could be 10 milliamps, 20 milliamps, 30 milliamps, 10 milliamps, 20 milliamps, 30 milliamps. If I pick a point on there, look at the results, I've got 6 volts divided by 20 milliamps. Now 20 milliamps is 0.02 of an amp. It's quite important that you get that. And that comes to 300 ohms.